So hyperbolic cosine squared minus hyperbolic sine squared. And I'm just going to manipulate this until I make it match, until I make it end up equaling 1. And with hyperbolic sine, hyperbolic cosine, the only things that I know about those is that I know that hyperbolic cosine is equal to e to the x plus e to the negative x over 2. And I know that hyperbolic sine is e to the x minus e to the negative x over 2. So apparently if I simplify this down, it's supposed to just equal 1. So let's go ahead and do that. So I'm going to have to square this. E to the x plus e to the negative x squared is going to be e to the 2x, because that's going to be the e to the x times e to the x. Then I'm going to get e to the x times e to the negative x. And when you add those exponents, you get 0. Then I'm going to get another e to the negative x times e to the x, which is another e to the 0. And then e to the x times e to the negative x is e to the negative 2x. Okay, so that's the top squared. The bottom squared is 4 minus e to the 2x. If I square that, minus e to the 0 minus e to the 0 plus e to the negative 2x. And if it helps you, I kind of did that a little bit in my head, but if it helps you to actually write it out as e to the x plus e to the negative x, e to the x plus e to the negative x, and do your foiling. Alright, so continuing on. I can go ahead and subtract these. They do have a common denominator, but I'm going to go ahead and change that to a plus and switch all my signs in here. So now what I end up with is I've got e to the x and I've got a minus e to the x. Those cancel out. So that cancels that out. I've got e to the negative 2x and an e minus e to the negative 2x. So those cancel out. And I'm just left with 4e to the zeros all over 4. And e to the 0, anything to the 0 power is just 1. So that's just 4 over 4, which is equal to 1. That's what I wanted that to equal. So it equals 1, and we've got the answer. And I'm going to say that the right side's a little more complicated. So hyperbolic cosine of x, hyperbolic cosine of y, hyperbolic sine of x, hyperbolic sine of y. Just a side note, I haven't done it yet, but it's only a matter of time probably, and I just want to kind of point it out to you. Try and pay close attention to not forgetting to write those h's in there. Okay, we've done so much with our trig functions, and now we've got these brand new functions which look almost the same except they have that random h in there. And it's really easy if you're working fast to forget to write the h. Okay, I've done it. You'll probably do it at least once. But I do just want to tell you to be mindful of that and try and avoid doing that. So try and as you're doing it, make a conscious effort to making sure that when you're dealing with hyperbolic functions, you have that h in there. Alright, so I'm going to go ahead and change these to what I know they're equal to. So that's e to the x plus e to the negative x over 2. Hyperbolic cosine of y is going to be the same thing, just e to the y plus e to the negative y over 2. E to the x minus e to the negative x over 2. And e to the y minus e to the negative y over 2. Running short on space there. Sorry about that. Alright, so then I can multiply those things together. It's going to be over 4. And I'm going to get e to the x times e to the y, which is going to give me e to the, we have to add the exponent, so I've got to write that as x plus y. E to the x times e to the negative y. Add those, but I've got x plus negative y, which is the same thing as x minus y. And then plus e to the negative x plus y, and then e to the negative x minus y, and then e to the x plus y minus e to the x minus y minus e to the negative x plus y plus e to the negative x minus y all over 4. Again, to subtract those, I can change the signs here. And that's going to cause those to cancel. It's going to cause those to cancel, which gives me 2 e to the x minus y plus 2 e to the negative x plus y all over 4. And a couple things we can do here. First of all, we can simplify this down. We can take a 2 out of everything and make it that. Then the other thing we can do is negative x plus y is the same thing as the negative of x minus y. And when we write it like that, we can see that that actually looks just like hyperbolic cosine, except that instead of it just being an x or just being a y, it's x minus y. It's e to the x minus y plus e to the negative of x minus y all over 2. That is equal to hyperbolic cosine of x minus y, which is what I was trying to show that it equaled. Alright, last thing that we're going to look at is using these hyperbolic functions. If we're given one, using it to get other ones, using it to get the other ones. And so with this, we're going to want to use some of those identities. So we just proved a couple of them. You'll prove a couple more in your homework. And all that stuff. And so now we're going to use those to help us figure out our other problems. And so in this case, we're never going to actually solve for x. Okay, it would take a lot of work to try and solve for the x value. So we're not going to do that. That's not the route we're going to take. We're just going to use these relationships that we have. So first of all, find the easiest one, and that would be your reciprocal one. So the reciprocal of cosine, hyperbolic cosine, is hyperbolic secant, which is going to be 4 over 5. So that one was the easiest one to figure out. So let's then look and see what else we can find. We can use, so pretty much you're going to want to stick with there's other identities that you could use, but the ones that we really want to focus on, the ones that are going to relate pretty much all that we need, is those first 3. Okay, so I know that hyperbolic cosine, which in this case is 5/4, minus hyperbolic sine, which I don't know, squared, is supposed to equal 1, and I can figure out what the hyperbolic sine is from here. So that's 25/16, not fourths, sorry about that. Minus hyperbolic sine squared equals 1. So negative hyperbolic sine, almost forgot the h, told you it's bound to happen, just be conscientious and be careful about that. 9/16. So hyperbolic sine squared is equal to positive 9/16, which means hyperbolic sine is equal to 3/4. And with that, we can get hyperbolic cosecant equals 4/3. And then we can also get hyperbolic tangent, because we know that hyperbolic tangent is just hyperbolic sine 3/4 over hyperbolic cosine 5/4, which is equal to 3/5. And then hyperbolic cotangent is just going to be 5/3. All right, so last one. Again, start with the easy, hyperbolic cotangent. So start with your reciprocal one. That's going to be the easy one to find out. And then look at your identities. Again, specifically those first 3 identities are what's really going to help you on these problems. And so I'll go ahead and look at that first one, which says that hyperbolic tangent squared plus hyperbolic secant squared is supposed to equal 1. So that's 9/16 plus hyperbolic secant squared. Subtract 9/16 from 1. Hyperbolic secant squared is going to equal 7/16, which means hyperbolic secant is the square root of 7/4. Which then means hyperbolic cosine is equal to 4 over the square root of 7, which we don't write it that way. We would write it as 4 square root of 7/7. Rationalize that denominator. All right, lastly, we need to find sine. And you've got a couple options here. You can use, since we know hyperbolic cosine, you can use that rule right there that we did, same way we did the first problem. You could also use your hyperbolic tangent rule and just modify it. So I know that 3/4, which is my tangent, is equal to my hyperbolic sine over my hyperbolic cosine, which is 4 square root of 7/7. And so I'm going to times this by 4 square root of 7/7. Which gives me my hyperbolic sine equaling, 4's cancel out, 3 square root of 7/7. And then my hyperbolic cosecant is just going to be square root of 7/3. All right, that is it for this intro to hyperbolic functions.